I have mentioned that the spindles on the CNC routers I use have brushes, one of each set being spring-loaded so that it pops, cutting power and protecting the motor's commuter. The CNC controller, having no knowledge that the spindle has failed, would continue to drive the stepper motors. So I built an L-box so a set of normally closed contacts could be put in series with the E-stop circuit. The spindle is powered with 230 volts AC. For the L-box, I use a 230 to 24 volt trafo and a small linear PSU producing 24 volt DC. These are wired in parallel with the spindle, so that when the spindle is powered, the L-box is powered. However, the live wire to the spindle is being fed through pins 1 and/or 2 to pins 3 and/or 4 of a chip ACS7125B. This is a Hall effect current sensor, the 5 amp version. This chip is powered with 5 volts DC and will output circa 2.5 volts when no current is detected. Depending on how connected, the current flow will change the output from 2.5 volts by 35 millivolts per amp. In this case, AC is being monitored, so the output could be greater or less than the 2.5 volts. It changes 50 times a second here. For the brain, I have a small component box to house a microchip PIC 16F676. This circuit is supplied with 24 volt DC and generates its own 5 volts to power the microcontroller and as a reference voltage to supply the ACS712 Hall effect sensor. This little component box has 2 inputs, which can be used as analog or 5 volt digital. One is being used here as analog for the PIC to read the current sensor's output. The PIC's component box has a 24 volt digital input via an opto-isolator and 2 open collector NPN transistor outputs to drive a relay and an indicator. The relay I use is double pole, one pole to break the E-stop circuit, which will of course cut the supply to the spindle and L-box. The other pole of the relay provides an alternative supply to the L-box alone until reset. The first of these boxes had the button indicator in its own little box, which will be shown. When this spindle monitoring box is first turned on, it will flash to indicate that it needs to be calibrated. This is done by disconnecting or switching off the spindle at the motor. Then with the button held down, the spindle is powered on. With no current detected by the sensor, the output is sampled and averaged a number of times, and the value written to EEPROM, plus a bit to indicate that the calibration was done. When normally run with the spindle on, the output from the sensor is red, and the difference between the value and the value stored in the EEPROM is saved. This is done another 31 times, and each time the result is added to the previous stored value and then halved. The final result has the lowest 2 bits, bit 0 and bit 1, cleared for hysteresis. If this final figure is greater than 0, then a 1 is shifted into a 16-bit shift register, else a 0 is shifted. The values used are 8-bit, as derived from the 10-bit A to D input. Inputs to the 16-bit shift register are once per millisecond. The 2 least significant bits, 1 and 0, of the value to be evaluated are cleared. So if greater than 3, then a 1 goes into the shift register, else a 0 goes into it. If all 16 bits of the shift register are 0, a double pole relay is turned on. One set of contacts opens the E-stop circuit to the controller. The common terminal of the other set of contacts goes to the live transformer input for this box. The normally closed contact connected to the spindle's live supply, which is also fed through the current sensing chip. The normally open terminal connects to an alternative main supply. This contact arrangement prevents this new main supply from reaching the spindle. The time it takes for the contact to hop from one contact to another while simultaneously instructing the controller to cut the spindle's power will not be an issue in terms of power glitches or brownouts, as will become evident should you listen on. The indicator on the button attached to the box emits a flash code indicating as appropriate. Elsewise, it communicates the values it is finding. A pause, then a stream of 8 bits, most significant bit first, as flash pulses. One flash being a 0, 2 flashes being a 1. It is surprising how often all 8 bits are 0, but they have never false triggered. When I built, programmed and fitted the first of these circuits, it needed to be tested. First, turn on and off the spindle with its radio button on the controller. Disconnect or switch off at the motor end. The new L-box should trigger until reset with the button, whereby it powers itself off. All okay. Tested with manual turning on and off the spindle. Next, to run it with G-code. I ran it a number of times cutting air, and it would fail. The behavior was erratic. Sometimes it would stop, triggering a shutdown after a minute, 5 minutes, whatever, whenever it felt like it. Sometimes the wrong flash code, and it would not trigger after manually breaking the power to the spindle motor. It had a mind of its own when run under G-code, but for some reason was reliable when hand tested. It turned out that the controller, by default, had a parameter box ticked so that when a G-code program was run, the spindle is automatically powered on. Changing this would have been a quick fix, but I left it as it was. The G-code is produced from CAD. When run, the spindle is turned on, the L-box powers up, a few lines of instructions, then an instruction to turn off the spindle. The L-box is running, but for how long? The spindle didn't have power for long enough for the motor to turn. You couldn't hear it turning or moving. A few more lines of G-code. The Z-axis is instructed to move to 20 millimeters above Z0. I normally started at plus 3 millimeters. When Z gets to plus 20 millimeters above Z0, then the spindle is turned on. Power is then restored to the L-box, if it is still alive. The regular G-code program, as interpreted by the router, is as follows. First line, a percentage sign, which means start of program. At this stage, the spindle is turned on, because that's the default. The L-box gets power for now. Second line, G17, select XY as working plane. Next line, G90, absolute position information. Next line, G71, dimensions in millimeters. Next line, M05, which means turn off the spindle. So this L-box has no power anymore. It's been on for, could be 20 milliseconds, it could be 50 milliseconds, it could be 100 milliseconds. But it hasn't been on for very long. The power supply would have charged up by however much it charged up by. Next line, G00Z20, so rapid to Z20. Next line, T1M6, which means select tool 1 and change tool. There's no delay for this because there's no automatic tool changer or anything in it. It just runs through that instruction and then accepts that that's the tool it's got. Next line, S8000, which is ignored because it's the speed of the spindle, and that doesn't get set in this. That gets set manually at the spindle. It's a knob that you turn for whatever speed you want, and the instruction following that is M03, which means turn on spindle. So the L-box has power again. Now suddenly power is restored to the L-box and the pick. So the L-box gets power for circa 20 to 200 milliseconds, loses power for a number of seconds, and it is then restored. Now, how good is the pick at surviving this power glitch? or should we initiate a fresh start at this stage? The MCLR pin on the pick is wired up and enabled. The brownout configuration bit is also enabled. With a fresh start, the chip input-output parameters, etc. are set and cleared as desired. That's as I programmed them to be. The RAM is cleared, or individual bits are set if I so desire. A number of free, unneeded RAM addresses are now written with a specific value which I give them. The program can check during each cycle that these values are present in the RAM bytes that I've put them in, and if they are and uncorrupted, it means things are okay, or most likely okay. If the information in those bytes has changed for some reason, it's not supposed to change, so initiate a reset. The program can check during each cycle that these values have not been corrupted. If they are, a reset is triggered. Following recovery from a brownout, after resetting all essential stuff, if there's been a problem, if there's been a drop in power and the chip turns itself back on. So these values are checked to see if they are intact and uncorrupted. If they are intact and the RAM seems okay, the main program can resume. But if the RAM is not okay and there has been a voltage drop on the chip, if the values that have been previously set in these RAM locations is still there and valid, it can be assumed that the RAM has survived and it would be safe to return to the main program. The problem is the RAM isn't okay. It seems okay, but it's not. There has been a voltage drop on the chip. The voltage on the two flip-flop transistors from the 6 transistors that make up each bit of RAM have been reduced to a critical level. Any leakage or each read of a RAM location will suck out a little more voltage. Whether it takes a minute or 5 minutes, the program will fail. The fix was not to clear all RAM and do a fresh start each time. If the known values in RAM are true, then it can be assumed the other values are still intact. So each RAM location is read and rewritten, restoring its flip-flop levels to their proper voltage, and then resuming with the main program, resulting in a recovery from the power glitch. So that's what I did, but I was expecting to have to revisit the program with the odd fail, but none has so far happened. So at this stage I can assume the RAM was uncorrupted and just needed to be salvaged by this method at the get-go. Have you ever been out with someone and they started humming or singing a song? The same song at the same note is playing unconsciously and simultaneously in your head. Some sound, street noise, would have sparked off the same neural network sequence in both your brains, yet neither of you know what the trigger was. Nowadays, I avoid listening to pop songs on my way to work. I could finish a task and wish to focus on approaches, possibilities, or even what the next task is. This is difficult when every time you break, this earwig that you had heard earlier in the morning starts to play in your head, distracting and interfering with your ability to think your own thoughts. Infected by a mindless melodic mantra, endless claptrap mindless boogie. Copyright law protects the right of those who produce this stuff, regardless of how many have been repetitively exposed and infected with it. If this stuff burns networks in people's heads, which can be triggered by external sounds, then should they not own it, or should it come with a health warning? Then if enough people are infected, these songs get associated with brands. Do you ever feel brainwashed, or is your mind your own? What causes you to want the latest consumer products, foreign holidays, a bigger, more expensive this and that? The facilitators of this crazy consumerism, constantly trying to increase GDP while producing nothing themselves and sucking up all the profits, while still leaving you wanting more. Maybe you need to be punished for your gullibility in contributing to man-made global warming, while you obliviously play mindless tunes in your head. Age 17, I spent the summer working in a food factory. I referred to it in a previous video. I was curious as to how metal was manipulated to make the stuff in jewellery shop windows. So I then moved to London, hoping to get work in Hatton Garden, where I could learn these skills. I got a job straight away, 35 quid a week, in a bullion dealer's. Silver is used in producing black and white photographs. Light turns it black. Film developers were not allowed to throw precious metal down the drain if it could be retrieved. The bullion dealers, free gratis, would provide them with a hosed container filled with steel wool, which filtered and collected the silver from the chemicals they used. I worked in a basement, crushing rusty bales of steel wool in a large iron basin with 2 large granite wheels, shoveling the dust for the next guy to smelt and collect the silver in skillets. A dirty job. 2 weeks later, I got a different job, 13 quid a week, as a trainee jobbing jeweller. This was quickly changed to an apprenticeship as a diamond mounter, that is, making the mounts that hold diamonds. That firm went bust, so me and my indenture papers were transferred to a different high-class firm. London was very refreshing for me. There was opportunity based on your ability, the colour of your skin, your religion or lack thereof, the length of your hair, dress sense or background didn't stand in your way. Unlike Ireland, where people brown-nose those they perceive to have more money than them, regardless as to how they acquired it, and try to crush those they perceive to have less, rather a sick society. Nonetheless, there are good people in Ireland, but less than there used to be. Anyway, soon after I arrived in London, I was with a couple of friends walking down Oxford Street, I think. There was a shop where they had removed the glass from the front, opening it up. A crowd of people were inside, a stage, spotlights, a guy with a microphone and a PA system. The back of the stage all lit up with fancy goods. Large colour TVs, sound systems, the type of stuff you would see on The Price is Right. The crowd grows as more people walk in from the street. The guy on stage is talking about how expensive all these items are, all recovered from a liquidation sale, and everything must go. 1-day sale. Every item, and all at the same price. Each customer is only allowed one, and only after he finished his long pitch. Once these bargains were gone, they were gone. A once-only opportunity of a lifetime. He slowly worked the unit price down from 1,000 quid to 15 quid. Over to the left front of stage were a number of people, each waving 15 quid for some time before he finished, getting more excited and pushing against one another to be the first for the bargains. When he finished, people started piling out on stage, carrying large glossy boxes. Then the frenzy began. The guys waving the money were being handed expensive gear. This was irresistible by this stage. I had secured 15 quid in my grubby little hand. Act or lose out. I held up the 15 quid. It was snapped from me, and I was handed a box by one of the guys parading out. What the hell had I just done? I felt like I had just been sucker punched. It was a stereo 8-track player and a pair of 4-ohm speakers. Although I had heard of an 8-track, I had never seen one, or an 8-track tape. Over the next year or two, after buying cheap food, usually canned stew, bus fare and rent, spending what money remained on tools, I would allow myself 40 pence on an 8-track tape from a market stall in Leather Lane on a Friday. It runs parallel to the garden. Many times I increased my tool budget by walking the 10-odd miles home from work instead of the bus. I reckon the 8-track was worth it, just as a life lesson. I have never been a big music fan. The 8-track would play over and over again until the tape was pulled out, so I became familiar with many of those songs. One song, Mr. BoJangles, I had searched for a number of times on the internet over the years. There are a number of versions out there, but they all sounded like poor imitations to the version I knew, which was by Bob Dylan. So when I discovered this 8-track and tapes in my workshop covered in dust and realized that that was where Mr. BoJangles was, I needed to see if it still worked. Scratches and clicks on songs don't bother me. I may be anal about aligning slots and screws or the like, but imperfections in music, for me, give it character. Is that odd? Leonard Cohen was back to front. Makes no sense to me. I must have unwound the whole tape and rewound it the wrong way at some stage. However, now I have the audacity to flip it, so who cares? There was a sample of Leonard Cohen's passing through here in the first edit. The words were, "Tell the people that we are only passing through." I was at Franklin Roosevelt's side on the night before he died. He said one world must come out of World War II. Ah, the fool. Yankee, Russian, white or tan, he said a man is still a man. We are on one road, we are only passing through. This little lathe had a 4-way tool post and HSS tooling. A quick change tool post of some sort is essential as part of the CNC conversion. The availability of suppliers that will supply this kind of stuff to Ireland are very limited, so choice is usually take it or leave it. When stuff manages to get this far from outside Europe, it usually comes with a demand for tax from the postman or the courier. If it comes from inside Europe, the market here is too small for companies to bother with the bureaucracy to supply here. Also, traditionally, there may have been a distributor or agency deal with a UK firm covering the British Isles and the Irish Republic, so they don't wish to short-circuit their UK distributor. Then there may be Irish distributors that may supply higher value items to multinationals from a manufacturer's range. They can get you what you want, but it will cost way over the odds in time and money. I found an offering from Banggood for a 250-100 tool post, piston type, also some carbide insert tools, and some for the bigger lathes tool post, the 250-200. Plus additional tool holders, all ordered together. The order was large enough to cover the cost of tracked delivery, which is necessary. Unfortunately, the order was split. Everything arrived very quickly, apart from the tool post. I would prefer an order was sent complete rather than in dribs and drabs. The tool post on its own would not be considered of high enough value to have proper track and trace shipment. Way beyond the promised delivery date, the tool post had not arrived. Banggood emailed me with a new revised delivery date. They emailed me with loads of gold stars, credits and discounts, and flashing emails for all kinds of products I could buy from them. I would go onto the internet, nothing to do with them, and there would be Banggood ads to buy the tool post I was still waiting for. I had no intention of buying anything else from them while they had not honoured their existing commitments. I ticked the box for them to stop sending me advertising emails, but they continued. When the revised delivery date had passed, the limited tracking information saying the tool post had reached London, wherever that is. I contacted them. They had already shipped out another one, 2 hours later. I assumed this was a time zone thing, the world being round. The new one got to London again, wherever London is, way after another ETA. By this stage, I had ordered one from the UK, a little more expensive. Plus I ordered 1.5-inch T8 backplates, a 5-inch 3-jaw and 4-jaw independent chucks. Banggood asked me would they send out another tool post or give me a refund. I replied that it was their choice and they gave me a refund. They also stopped sending me those flashing advertising emails when I clicked the desist box for a second time. All good, but over 2 months' delay. There is a slot on the cross slide where I could have mounted a second tool post if I had one, but at this stage I am considering other uses for that slot. I have watched a number of YouTube show and tell videos of people discussing their new tool posts and tool holders. I find it a little unsettling that so many will remove and trash the set screws, a flippant cheap Chinesium, and buy new ones in their local hardware store. These screws may be hard. Maybe the heads could break from being a little brittle, should they be regularly loosened and tightened, having plenty of bite. With a quick change tool post, they tend to be locked down and rarely interfered with after that. With a 4-way tool post regularly swapping out tools, a softer screw may be desirable. Maybe this is cultural hand-me-down behaviour from an age when the quality was less good, or maybe a hangover from when they first tightened a metric set screw and used the wrong Allen key. When my first tool post set screw fails, I will replace it. But poo-pooing and trashing stuff with undertones is a behaviour that people should question in themselves. In the first edit, I played a sample of the earwig that motivated me to resurrect this 8-track, Mr. BoJangles. I didn't see any issue in sharing a sample, complete with USB clicks and imperfections. Unfortunately, the man claimed copyright. I disputed, and they upheld. The video was blocked. I can't help but feel this restricts and retracts my sharing of my history. Can I protect and defend this? Turning greys to black and white? That's not me, Bob. I'm sorry, but that's not me, Bob. Were words just sounds to lace a score? Maybe times have changed, but this ain't no brave new world. Maybe I should stick to ironry. Ciao for now. Dylan's version of Mr. BoJangles is available on Spotify. Cone songs are all on YouTube.